Hello, folks. We're gonna do just a little bit of work today. I figured I'd do a short-ish stream. We'll see how well or how long this goes, but let me just sort of start and show what I've been thinking about a little bit. So, welcome, and Deck, welcome. Um, so this here is one of the curves that we just found kind of randomly during a sweep. Hey, Tim. You can see here we have a score of 20.5 in 13 seconds. But if I do it in steps, it's actually below 2 million steps. Okay? And if I instead go to all of these runs that are all good, right, we can see that we have step solves up to, this is like 5 mil, we've got 2 mil. But then if we go by time, we get all the way from down to 3 seconds up to anywhere over here. So this means that this is a pretty solid environment for evaluating this trade-off type of a thing. And I think we can even just do this, right? If I just go... gonna be... X-axis will be... this. I need to find a better replacement for this. Honestly, Neptune used to be good, but it's like, look how crap this thing is. Oh yeah, 250 search results. Let me just take 5 seconds to search that. Good. Honestly, I should just do that. Okay, so we get a front here, right? And actually, it should be... we care about the lower end of this front here, right? So this sort of curve, if we draw this, right? We're getting this, like, this nice fit here. So didn't I get Epic Pen? Yeah, I forgot I got this for this stream. Come on. I'll just draw it. Right? You see this sort of fit here? This is what we're interested in. We want to see if we can spend more compute versus more data. So I don't think that it needs to even be this much compute. I think we can even cut it at 30 because it's just running the trials for too long. Even 20. Even this, like, little chunk of the frontier is useful to us. This is going to be the graph that matters in RL. So, this min needs to go down to 1e6. And timeout needs to go down to like 30 or 20. And 20 spread. Meh. give it 30. And then I have to figure out what we do with the pareto frontier, right? Is there a simple... If I make one cost metric out of it, it's easy, but I don't think that's what we want to do. Let's think about how we do this. Yeah, so I have a single cost here, right? We're just gonna split it. Is that what we're gonna do? Can probably do both. I'm actually a little curious here. Do I just add one more to this? Can this do multivariate? Like multivariate output? Last mention is the number of data points. Maybe we can. I wonder. Welcome, Georgie. Button shader. Alright, what happened here? Downsampled. You can't downsample this, huh? Ah. Let's see. Hello. Welcome, Owain. I hate LaTeX, yeah. Papers are a pain. Yeah, because like trying to have like a human hand mimic like the actual physical operations is like the dumbest conceivable way of doing that, right? And just everything should be done through the software. Hey, how's it going? Yaxine, if you're not using a debugger, you are straight up trolling. Like, you were, like, hard trolling. Welcome, though. How are all your crazy projects going lately? Oh, oops. Yeah. Debugging. Yeah, for all the bugs that your LLMs mate right for you, right? It's learning from pixels. Frozen embeddings makes it learn 3x faster. 3x faster wall clock or steps? You have to actually compute the embeddings for your new data, yeah? Which would be a bigger model. Wall clock? That's amusing. Well, I suppose it depends on the base architecture you're using as well. Like, a lot of the from pixels stuff kind of sucks. Um, if you use, like, the original ConvNet architecture from, like, Nature CNN or whatever, that's awful. You can use the Impala one, which is a slightly deeper ResNet, but it's annoyingly slow. This is the reason we don't do pixels, man. It's not because pixels are a harder problem. It's just because everything gets slow. Really annoying. Slowness is killing velocity. Yeah, it'll do that. Honestly, like, I'm at a point here where I have to do work on sweeps, and it's completely killing my motivation, and the individual experiments are only like 30 seconds. But, you know, my whole experiment is having to run at least 100 of those in a sweep. I don't need to do it off vision alone, I really wanted to. If you can just have something set up where at least most of your experiments can be done from state, right? Even if you have to go to vision later, I, I would try to do that very strongly. Like, because the other thing, Yaxine, right, is like, you can train an encoder fully supervised, right? Like, if you want to do a frozen embeddings thing, if you have a good state-based policy, that means that you can actually generate yourself good vision data, right? Like, there's a lot that you can do. Borrow 256 H1Gs. Also, H100s are usually not even faster for RL. Like, to be fair, I haven't tried really heavily optimizing BF16, so maybe. But most of the time, our networks are so small, like, they're not even faster. I see. Connect on the embeddings also on CUDA ray tracing. Or A100s. Yeah, A100s are about, like, I'm pretty sure 4090s are faster than A100s for most RL stuff. Like, I would just suggest if you want cheap compute, just go find on Vast. Like, people have nice multi-GPU boxes with either 4090s or 5090s. I would just do that. I don't know if you can get access to the RT cores as well, but the consumer cards have RT cores in them. I don't know if they're, like, nicely exposed in the way CUDA is. But technically, your chips literally have hardware on them for ray tracing. Like, that's all it's designed to do. So you should be able to use that. Too much work. Gonna try scaling on CUDA. Off state, loop on that, figure out how to learn, generate the state off the sim. Yeah, that would be better. I don't know what you're trying to do in the latest crazy iteration of your stuff. I'm mostly kind of beat these days. I did a really hard block of research for like 3 weeks. I posted the article on it, right? I like actually found a clear-cut mathematical reason for a lot of the stuff I've been saying for the last year or two. I know what to do next. But yeah, I'm kind of just chilling and doing a few things on this in the meanwhile before I really start going on the next big push. That and finishing this batshit crazy cut that's driving me insane. RL is very weird, but it's getting better. I mean, honestly, that article makes a lot of stuff make sense now, right? I think on the algo side, the holy grail would be like a really, really clean method of using of combining like on policy RL. Well, it's of combining long form bootstrapping with data reuse. I suppose that's what it is. But even before I get there, I basically figured out that I'm going to be able to get like at least 10 to 20x sample efficiency just by fixing up my hyperparam tuning. We're going to do that first. We're going to make Puffer able to be, really the best thing out there for anything from moderately fast to very fast M's, not just very fast M's, right? And moderately fast M's you can usually get by just scaling up slow N's for practical stuff in industry. That's what I'm doing next. And then from there will be more opportunities. Yeah, sweep. I mean, this is what I'm doing right now as I'm working on here. I'll show you the graph. This is going to be the most important graph in RL. This is the crappy version of it, right? Whoops, let's not make it go below 0. That's really dumb. But yeah, this. So this is going to be the most important graph. This is the data compute trade-off. So it's this frontier. Can I use more compute to use less data, or can I use more data to use less compute? And have this automatically figured out for your specific problem. And ideally without all this squiggly mess over there, right? Without all these bad samples. This is the thing I'm doing at the moment. Did you need pointers on any of the rendering stuff or whatnot? I mean, the biggest tip I can give you is to do whatever it takes to keep that dev loop tight. It's really tough when it isn't. Honestly, good? That's good. I haven't messed with rendering much for the exact reasons that you're encountering right now. And I frankly have a ton of other stuff that I can be doing outside of that. You ripped out Madrona's ray tracer? Yeah, that's exactly what I would have suggested doing on a PyTorch stream. On a PyTorch stream. Are you doing it just in PyTorch tensors? Like pure PyTorch tensor ops? Or do you have it hooked in? Ah, jeez, that's so limiting. So the cool thing with Madrona, right, is that you can write arbitrary, like you can do arbitrary CUDA and stuff. Oh, I have it hooked in. It's a PyTorch. It's an extension, but it's not pure PyTorch ops, right? Like you can write arbitrary logic and loops and stuff. You're not doing like a JAX thing where it's just a bunch of tensor ops, right, through Python. Okay, that's better. Yeah, as long as you have that, as long as you're not reinventing JAX in PyTorch. Because, like, the thing people forget, right, is, like, you don't have to do everything in bloody PyTorch to keep it on the GPU, right? You can do it in CUDA, and the data can stay on the GPU and just get cast to a torch tensor for free. Physics in PyTorch? Pff. If it's simple, but I don't know. I think you find rather quickly, right? If you're going to be reinventing JAX style stuff and you go read JAX code for more complicated projects, it's not fun. No collisions in the loop is faster. Yeah. So it's like once you start adding stuff to it, right? Like once you start trying to add more features and stuff, and then you realize, ah, crap, I need to do loops, right? Then that's when you just stop using the high level thing and you use the low level thing, right? Right, some CUDA or whatever. Right, CUDA and make an extension. Yes, exactly. And we have a very small sample of that with my advantage computation, right? Puffer has a PyTorch extension for that. Super annoying. just do this. Yeah, Super Maven's really nice, right? It's really stupid, but it's really fast. So if my brain were actually working today, right, it's like you're just no longer limited by typing speed. This is all I use for code, Yaxine. Like, I don't do anything else. I don't have the freaking bloated ass agent this or that, right? We dev real agents around here. Literally the only thing that matters is that the thing is good enough and that it's fast. Dude, I don't see how you have get any enjoyment out of like wrangling LLMs all day. Like I would go batshit insane and like go run away to a forest and become a monk or some shit dealing with that. Yeah, so for me that's just equal to typing buff, right? How I see it. Maybe I value the control too much, but I don't know, I don't like stupid shit fucking with my code, and especially when it's not a person who I can like actually give feedback to who will improve over time. I have a lot more focus though on the I have a lot of focus on the code itself, not the output. Like Puffer is not just the output of what it can do, right? Like the simplicity and the structure of the code is a large part of Puffer. Large part of programming for me, really. Okay, that's not bad. Off policy RL for continuous. So Rob, off policy RL is a mess for the reasons I outlined in my most recent article on X. We do almost exactly on policy RL for everything in Puffer, and there are advantages to off pol RL. They're currently not worth it, and it's going to require like a fundamental change in RL capabilities to actually leverage what off pol is good at effectively. Don't read every single line. Yeah, no, I hear you on that. It's just, I don't know, spending all day reading crap code instead of just writing a little bit of good code myself. Not my idea of a good time. Because it's like, when stuff is done stupid, I can't just go edit it line by line. I have to redo the thing. Yeah, this is a way, way lighter weight setup, though, than what it seems like you've been posting about on X, right? Like, this really doesn't do a ton for you. This just, like, eliminates typing speed as a... Like, pretty much just eliminates typing speed as a bottleneck. No, I'm not a crazy fast typer. I can type maybe, like, somewhere between 80 and 100, maybe 90 on a good day, WPM. And then this is just, like, takes that to effectively. And it's not like I'm going to be writing the code so much faster. It's more so just that, like, while I'm thinking about stuff, it's like it reduces the barrier of, oh, I'd actually have to, like, type that to try it. Mm-hmm. Yeah, 110. You will eventually be, like, a fast... most people would eventually be that fast if you've been doing it for long enough, right? In my case, like, I have feet for hands. I don't know. My dex is, like, the dump stat, I guess. Blowing off ball for my problem because I'm data capped. Yeah, so that's the hard thing. So, Rob, basically, the article will outline pretty much everything. Off-pol does work, but it's very brittle, and it can literally be 1,000x slower than on-pol. That's the problem. So, like, the trade-off is it's scalable, but it's a really, really bad compute to data, like, trade-off. There's not, like, a good region of it. The fuck even is that? Oh, that's the chair, isn't it? Isn't that the chair? Oh no, that's the keyboard, the Kinesis keyboard. Nah, that's not gonna help. I guarantee you that's not gonna help. I don't know, my Dex is always just, like, just sucked, you know? Bad at every game ever. Handwriting's bad, write super slow, that sort of a thing. Yeah, I'll show you what I got. What's this? Is this the old one? Okay, yeah, so this is the old one. I have the newer one at my, at the other place, but... Let's see. Black Widow, Tournament Edition V2. I like it. Newer versions are even a little better. Means you pay attention to detail. Not particularly, I'm just slow on things. The funny thing is, it's really not that big of a deal for most stuff. Like 90 WPM versus like 120 doesn't actually make a difference in your day-to-day hardly at all. Yeah, good keyboards. I mean, they're over, like, people say, a lot of the Razer stuff is overpriced. Um, but it is, like, pretty good. I have, like, pretty much the full setup. This is a Death Adder V3 here. I got these, you know. It's just my go-to. And the webcam here is Razer as well. And heck, the computer case and the mouse mat and the freaking monitor. I got a lot of Razer stuff. And generally just a good company. We're working on here in Puffer. I'm trying to add in so I'm trying to add in data time steps as well as time spent. So like time in steps versus time in wall clock, and have these both be part of Optim. Got a whole setup for 500. Nice. Fuck, the peripherals I have here are more than that. And the thing with with Razer stuff is like it actually does improve every generation. So whenever they release something new, it's like I kind of want that because you actually can notice the difference like most of the time. Like for instance, my this thing's all torn up, right? This like wrist rest is just all torn up. They made it like they made it feel nicer and way more durable in the next version. I have one of those at my other place. Ah, okay, so this actually does work. Cool. Now this is the question as to what we do for Frito points. Or keep dim. Keep dims. True. Look at that. So Okay. Damn silica RL. I'm not quite that big now, am I? The cut's driving me a little crazy, but I don't know. Not gonna be looking like that, but hopefully should be quite good soon. I gotta go set myself up like a Dexa or something. Log C. Oh, this is wrong, isn't it? How'd this get messed up? How do you deal with sleep? What do you mean? Actually, so for whatever reason, like, being hungry is the least difficult of anything. Like, I can basically starve myself and just not really care that much. It's the fucking fatigue that's just brutal. Because I'm running probably average like 40 miles a week. And I'm also lifting 5 times a week. So the friggin' fatigue is just brutal. Being hungry is just whatever. Easiest part of the job. Wait until you have a kid. Hey, that's self-inflicted, my guy. You know what you signed up for. Not exactly the best advertisement. How the heck did this happen? Yeah, well. I mean, good for you, man. At the moment, I'm chillin' focused on my research and stuff, though. Not something I'm going to be thinking about for quite a while. Yeah. Really not my style, man. Really not my style. Lambda x one line. Uh it needs a function. It's just a detail of GP cost. It needs that like specific thing needs a function. What the heck did I do wrong? Oh, I'm just dumb, right? Yeah. 0. I see. This just needs a transpose, right? T. Yeah, let's just do like this. This will be better. All right, so this is good. Okay, so this is going to have to be... I don't even know why I have this stupid thing in here, right? This is never freaking used, ever. Get rid of that crap. It's from carbs. Huh. That's fun. You doing robotic stuff then? That's cool. Wait, why is GPY norm? Wait. Suggestion scores. Ah. Oh, I see. This, right? Convert. Transpose needed. I think I transposed it back. Pick in place with Isaac Sim. And Isaac Sim, man. If I ever end up doing like actual hard robotic stuff, I'm going way lower level than these engines. Yeah, that's a cool thing to do. That's like an actual fun thing to do. So nice this is in Python. Is it? I don't know. I'm way happier when I'm writing C. Hey Finn, hey Sam, how's it going? What do I do? List format. Print. Okay, do we have it? Yes, it looks like we do have it. Very nice. So, if I have not catastrophically messed something up, what this should now do is this should attempt to expand. Let me get this right. This should treat cost in terms of both steps and time. I think I might have to rethink a couple things. Hardware's still hard. If I can get you guys better drones, right? I will gladly do that. There's actually, I've totally forgot to reply to him. P Money in the Discord. I think I just like missed his DM or like I saw it and I totally forgot. Cool. The guy that I talked to said that he has his lab just has like crazy fly drones, and then a ton of spare parts because they get busted a ton. Okay, so I'm now realizing, right, hang on. Looking at different hardware, but it's hard to find stuff that's all in stock. If you message P Money in the Discord, he might be able to point you to like a list of stuff. I'm happy to just send you more like parts and stuff if we can find stuff to get. Didn't include time steps. So before Drover, we were running almost all of our experiments, pretty much all of our experiments, just on wall clock time. You could set it to do steps instead. But what I want is, let me explain. So this is what I think is going to become the most important type of graph in RL. This is the compute to data trade-off frontier right here, right? So this is you can spend more data or you can spend more compute. And then what you're going to be interested in practically is like the shape of this elbow, right? What you're going to end up being interested in is in like the curvature here based on different problems. You know, when can we spend more data? When can we spend more compute? And then you want to push this frontier, like you want to push it this way, right? So you could end up, like one way that you could make progress, let me get this right. Yeah, so like one way you could make progress is to make the front look like this, so that, you know, you don't need to spend as much compute and you can still do well with few samples. And another way to make progress, right, is to make the frontier look like this, where like this. Yeah. So where you can spend even less compute or whatever. Or really just to pull this down at all. So, you know, this is new. It's not done yet, but like this is the type of thing that needs to work for RL to be good. I'm trying to think how... I guess I can run this and see what happens. It's linearized, right? Why don't we just all copy the far right data points? Because the far right data points, this is what Puffer was doing, right? Which is saying, hey, if I just have unlimited data, I can train in seconds. But when you have slower simulators, this becomes less practical. So, like, maybe Puffer's been focused on, like... Actually, I can show you exactly. This is where... Oops. Okay. Maybe, yeah, let me explain this very clearly, okay? So, this is where Puffer has been focusing all efforts. Is this region here where we have a ton of data and we can train super fast. This region up here, like literally 1,000 screens this way, is academia. Which is why I complain so loudly about the stuff that's done there. It's like this completely impractical frontier over here. The actual thing that needs to happen is we need something that's like... I guess this is 5 mil min. It should probably be like over here at like 2 mil. But like, let's say here, right? This is where we need to be. So I think Puffer is closer to where we need to be by a mile than where academia is, but we still have to do this. So, we need to be able to spend a bit more compute, but not a crazy amount of compute, and use, a fair bit less data, but not like no data. That's what we need. Puff is slightly questionable in the UK. It's just it's like, yeah, people think it's like a marijuana thing, right? Is that it? It's not like a particularly bad double. Let me look this up. Not on my main screen. Did I miss something? Okay. Is that actually a thing that you guys say? It's like a weird UK slang. What the heck? I've never heard that used. Is that actually like even a remotely common thing? Or is that like a super niche? Or is that super niche? It is? How the hell have I never heard that? Not really used now. I figured it was like, huh. Y'all have a lot of weird slang in the UK. But PUFR is kind of weird. Never heard it. Huh. That's funny. I mean, I'm not gonna change stuff over, like, if stuff is niche. It's kind of ridiculous, too. Like when Nips decided they were gonna rebrand to Nurips. Even though I guarantee you, like, they offended 0 people ever. I don't know, UK slang is super funny. I nearly died laughing the one time in grade school that like a British girl asked me if I had a rubber. I was like, "What in the heck?" It was like, "Oh, okay, that's what you call erasers." Yeah, you should probably go double check that one in the US. Uh you probably double check that one. UKers. Insufficient freedom. So you talk about the imperial system of being, pounds, but we have the imperial system of bullets per eagle. I had an eraser, yes, Drover. Funny, man. Working hours shifted -6. All right, so here's the problem with that, Tim. It's very difficult for me to get through my exercise routine efficiently because of how tired I am. All right? And when I get up, I have to go for a 6-mile run. I've got to do all my lifts. I've got to get breakfast, and then I've got to get myself cleaned up before I can start work. So, if I'm not feeling super beat up, I can get all of that done by like 10:30. If I am feeling super beat up, then it's going to be 12 or 1. Government's acting like the roaring 80s. I don't think any country ever has said their government is all right, other than maybe El Salvador right now. Maybe this is fine as is. Yeah, because it's just we're asking this to pick. We're asking this to pick a cost. We'll try this and we'll see. We'll see what happens, I guess. Hi there, I've started working with PufferLib since I saw you streaming last and delved into this whole world of RL trying to wrap my head around wrappers and environments. Welcome. It's a bit of a messy field, but we're making it much cleaner. Okay, I mean, we have this thing at least good enough. I may as well do this for now. Things are getting a little less popular. Yeah, I think it's mostly the guys, the El Salvadorans who are still in the U.S. I mean, like literally any of the Uber drivers here that are from El Salvador, all they want to do is tell you how much they love their president. The drone make the guy crazy fly, Sam. They seem fine. I can definitely get some. I can get crazy flies. I would have to get you, at the very least, like a stack of extra rotors or stuff. They basically just keep tons of spare parts around because they break constantly. They're not durable or anything. Too expensive, are they? A few $100. Buy these. Yeah, I'm more than happy to send you guys one of these plus like some spare parts and stuff. Like it's way better than like wasting your guys' time having to fight like stupid hardware. If this is actually like if you can actually get this stuff running nicely, I'd be very very happy to have Puffer running real drones. Mojo, what is Gymnasium Docs a good start? No, Gymnasium Docs are not a good start at all. Check the stuff on Puffer. Like, the thing is, we don't even go through Gymnasium except for their Spaces API. Like, the vectorization in Gymnasium, most of the like default libraries that use their core env API are just horribly, horribly slow and overcomplicated. AI add-on is another. What do you mean the AI add-on? What add-on? Like, control? What are these sensors? And that's either way, Finn. That's still fine if it'll actually work. Like, I just want to see Puffer actually work on, I mean, I want to see Puffer actually work, right, on this stuff. Why are we at 30 million steps? Okay, fine. Working with you amazing makes you appreciate Puffer more. Yeah, this... I mean, there's just so much in RL that still needs to be ripped out and replaced. It's kind of crazy. Better at these for tomorrow. We ruled them out. I mean, I told you guys that I was fine sending you new hardware, right? Like, if you think about it, right? Like, your time is not worth nothing. Like, you guys are capable. If I can just send you guys slightly better hardware and have awesome RL working in Puffer, I'm very, very happy to do that, right? And then, you know, that we can have a cool showcase. We can see a cool thing working in Puffer. I'm happy with that. You know, you guys get a cool project out of it. Maybe we even attract some industry people and we can set up like some actual professional stuff that I could bring you guys on for. A lot of stuff can come out of that, right? Looking for lines of constant perf. No, Owain, I'm just generally, I want to know the frontier, right? The goal is to have the curve. I want to know the shape of the curve, and then I want to push the curve down in any place that we can. Mm-hmm. Yeah, like Sam, like if you guys are feeling stuck with stupid firmware, like you can tell me that stuff way earlier. Like you don't have to drive yourselves crazy, like doing like fighting annoying things, right? The whole point of a lot of what I'm doing here, right, is to make RL fast and easy and sane in whatever way I can. Top contributors have access to advanced resources. Yeah, so in their case they need hardware because they sent me like a really cool drone env PR and have been working on that ever since. Generally the thing is that people who just need like training compute, if you've built like a couple good environments, then I do have hardware explicitly for that purpose. So here I have was it 8 or 10 desktops at this point with 4090s in them. And then we also have a couple multi-GPU boxes. So typically I give contributors who need access to a box, I just give them SSH to one of these boxes. They're all nicely set up. They've got backup power and all that. The curve being points. So here, let me explain this curve to you, Owain. So each of these points is an experiment. And specifically, I'm filtering these by experiments that have actually like mostly solved the environment. So here we have a set of hyperparameters where we've ran an experiment and it has solved Pong in 30 seconds after 6.5 million steps. Down here, it's solved it in under 10 seconds, but using 24 million steps. So what we want is we want to know the curve for like how much data versus how much compute do we need. These points over here are just considered bad because they're not Pareto optimal, right? They use more compute and more data. That's just worse. So if there's anything that is down and to the right of a point, it's bad. Yep. And Aziz, while I don't advertise this because I don't like to I don't want to try to entice people into doing free work for the potential of doing paid work. It is true that uh, we have had multiple people get very good and be brought into professional work with this type of stuff as well. There's a much higher bar for that, but it is a thing. At least one array to stack. What? Yeah. Yeah. So that is that is what I'm trying to do here. Oh, we have a fair few folks on YouTube today. Welcome. If you're new around here, I do RL research live. I stream all of my work. And you can find all of it. It's all open source. You can find it on Puffer AI. We have all sorts of demos here, most of which are made by contributors, many of whom came in with no RL experience. If you're interested in building cool stuff and actually having RL work on it, stop by, join Discord, follow all that, and get involved. What sort of search are you using to find the curve? How are you changing hyperparams after each new point is added? Another article on X or that Owain. Protein. Protein is our hyperparameter sweep algorithm. It is something that I developed. It is based off of Imbue AI's carbs algorithm. So, of course, the successor to it we call protein. All right, letting you set up League RL. Better than you would expect. That would be fun. I think the main qualification I'm missing in that department is simply not being good enough at League. Friggin' hard stuck bronze. Documentation is not that clear. Puffer wrappers work and so on. So Aziz, there really aren't puffer wrappers is the thing. Like if you look at other RL libraries with tons of wrappers, like there isn't documentation because puffer does not have them. Like our native environments do not have wrappers at all. Like if you're like looking at all those wrappers in Gymnasium and being like, well, why aren't these documented in puffer? We don't have them. They're slow and they're bad. What comes after protein? Probably creatine. Imagine the compute needed. Yeah, so this is, I mean, one of the things I'm doing right now, right, is we're trying to figure out the compute data trade-off. Because if you had a AAA game with good state-based obs, and you had it running at the speed of Puffer environments, we could solve that very easily. So in some sense, the only problem that they have is that their games are not fast enough, right? AAA game studios. If they were fast enough, we could just solve them. Puffer, I need to work more. Yeah, so Aziz, if you try to compare Puffer to existing libraries, you're not going to have a good time because Puffer is tiny. Like, it's tiny compared to a lot of the other libraries, but it's like just, it learns better, the algorithm is better, and it's 10,000 times faster in some places. So if you really just go through Puffer as its own thing, you'll have a much better time. Like the guide that I wrote as well, like the RL guide that I wrote, if you follow that, like you will be solid on RL. This is how our best contributors have learned. Exactly. Just start, like, basically follow the guide. You start, it'll tell you, right? Like, read this. Okay, now build this really simple env. Okay, cool. Now you can read a couple more things. You can build a more complicated env, and you build up from there. Because basically, I don't really spend a ton of time. We do have docs, right? But I spend most of my time not thinking about, like, how do I document things better? I spend most of my time thinking about how can I delete this stupid thing so it doesn't have to be documented, right? How can I make Puffer more compact, simpler, easier to understand on its own? Easy to set up. It's mostly speed, FBR. Speed's the main issue. I don't know why this thing has. Hmm? Flare, Lab Fast M's, Craft Decks. Yeah, of course. So, um, the guys, well, the guy that writes those is incredibly talented. I couldn't do that. Uh, he would be able to write those M's and have free time though if he just did them in C, and they would be faster. Like you can make jacks work for complex M's if you really try, but like it would just be easier and faster to write them in C. Like CraftX is really not fast on the scheme of Puffer environments. Like 100,000 steps per second. If you just ported the thing to C, it would be like at least 1,000,000, probably more. So there's really not even a trade-off with a lot of this stuff. It's just like we kind of figured out the way to write M's and to make everything fast and easy. And it's just, you know, you do it or you don't. The more stuff I see about jacks, like at least for environments and simulation, the more I just think it has no redeeming qualities. Interesting. Doing weird things. Protein have any work to be done on it? Absolutely. Yeah, absolutely. So right now, right, I'm trying to figure out it needs to be able to better model instead of just one cost, it needs to be able to model two costs. That's what I just added. I don't know if this works yet. The other thing that's weird to me is so in protein, one of the big things that I did was I gave it a downsampled representation of the entire learning curve. So instead of just giving it the like the last point of your training curve, you get a downsample, like you get 10 points on your learning curve. You're getting way more training data basically. The problem with this is for some envs, this just doesn't work for some reason. Like it makes protein not work correctly. And then also the Gaussian processes are like really slow. And I don't know if there's a way to like just make this thing run faster or what, or to understand what's going on. I think just GPs really just don't scale well with data at all. It's like cubic or something. So yeah, there's a lot of work to be done. I mean, I would love to not have Gaussian processes and Pyro and stuff at all and have like some sort of other model. But from what I've seen, it's kind of tough to replace them. But they're so brittle. Like, there are just so many details. Um, so yeah, I mean, there's a ton of work to be done on hyperparam sweep stuff. And making hyperparam sweep better would be very, very valuable. I don't necessarily have a super concrete list of things, though, that I would necessarily go and try to do that, other than just, like, playing with it more, running more experiments, that sort of thing. It's a core research task. And good hyperparameter sweeps are really, really useful. I mean, the other thing to think about, right, when we're designing our algorithms, so hyperparameters introduce additional degrees of freedom, right, into your algorithm. Um, the more degrees of freedom you introduce, technically, the better you should be able to do if you tune those degrees of freedom, right? But what you want to do is you want to strike a balance between having enough degrees of freedom that stuff is nicely tunable, but also not having like so many degrees of freedom that you need to run huge, huge hyperparameter sweeps for every new problem, right? Like, to what extent can we just find, okay, we can take out these hyperparams and we can always do at least 95% as good as the tuned ones, but we don't have to run so many experiments, so on and so forth. It's quite a bit of work. Like, for instance, right now, I have no idea why the hell it's running so many experiments with tiny models. Like, it's just deciding to run all these experiments with 9,000 parameter models, and I have no idea why the hell it's doing this. See ya, Sam. Someone working on a tower defense, or did I dream that? I did see somebody working on a tower defense env in the Discord. I don't know what happened. The Discord moves really fast now, and I've kind of been out of the loop. I really should be like more up to date on everything, but I don't know. The way I work a lot of the time, right, is like I get obsessed with a problem for a few weeks. I like work hard on the problem until I solve it or whatever, or like I burn out on it. And then like I kind of got to just chill and think about stuff for a bit before I work on the next thing. I kind of tend to work in cycles like that. I mean, it's finding interesting stuff. Those right. Best way to look into protein is carbs paper, protein post. You can go look at the protein post and then use the carbs paper to fill in the gaps. And then look at the code, right? It's actually, protein is a simpler algorithm than carbs in some ways. And the post that I make breaks it down pretty nicely. I think that's the most math heavy article I've written though. Math is kind of annoying in that one. Like, even, like, the way that they write down the Pareto optimality condition, it's like this annoying set notation that takes you, like, a minute of, like, thinking about it to see what the hell they're even saying. Because it's like, the set of all points such that for any, like, for each point, there does not exist a point that is better in both this metric and that metric or whatever. But if you just understand that it's like, yeah, we're looking for points that are Pareto optimal with respect to cost and score. Okay, if you're a math major, then you're good. Math is the weakest part of my toolkit. So, it drives me nuts. This is super weird, right? Like, that's a tiny little network. And that's a solve right there. Like, that's actually just solved with a tiny, tiny little network. I mean, I don't think it's not like a Pareto point, right? Yeah, it's right here. But yeah, it doesn't seem to be... It's not really doing what I would expect with this. Maybe it is just the case that Pong is so simple that you just use this tiny little net. I'm worried that it's, like, stuck on this somehow, though, right? Like... No, that is including an LSTM. It's just a tiny LSTM. Could be. Yep, tiny LSTM. It's just that it's doing, like... I let it go all the way down to 32 hidden dimension. And it's deciding to run a whole bunch of experiments at 32 hidden dimension. I mean, to be fair, it is getting results, I suppose. I suppose that's the issue as well with the way that this is set up. Like, it samples based on Pareto points. Black box optim's really obnoxious. You can actually make 512 hidden fast. Um, you can definitely make the networks work at that size as well. We have problems for which we use even bigger than that, but the learning rate's going to change. And this is if you integrate MuP into Muon, then the learning rate should be able to be stable across model sizes. But right now, the learning rate's pretty dependent on the model size. So that's the key distinction. I missed. Did some work to make. Well, I made some edits to protein to hopefully allow it to do the frontier of compute versus data cost. That's the main thing at the moment. But it's being super weird. Like, I mean, I don't know. What do we think, guys? Do we think that it's literally just the case that the smaller model is better because Pong is really easy? Pointernet will be solid on chess. Yeah, I didn't want to give it to you up front because, like, they're kind of a pain to deal with. But it seems like it would make sense. As long as you can get the env to be fast enough, right? I think you should be able to make that work. It sort of depends sometimes, because, like, getting pointer nets to be fast is also another thing. Fast-ish, maybe. You can get it into hundreds of thousands of steps per second without too much trouble, though, I'm sure of that. I'd like it at millions, no? Ops and action space. It's tiny. It's like... It's like 4 or 6 numbers. It's like the positions of the paddles, the ball, and maybe 1 or 2 other things. Action spaces just move the paddle. I think it's like up, down, or like stay. It bothers me. This thing has just run a ton of experiments, and they like just too many of these experiments are just bad, right? Maximum hidden it solves with. Oh no, I can get it to solve with whatever hidden I want. But it's the fact that the sweep algorithm has pushed it to the lowest possible model size for most of its runs. Mm. I would doubt it because you don't get hardware benefits below a certain point. I would kind of doubt it. Oh, you know what? Hang on, I might have this wrong. Yeah, hang on, I think I have this wrong. It's trying to do sample F and okay, I see what's happening. It's trying to do speed and sample F at the same time. Let's see if this does. Let's see if this does anything different. Okay, I mean, it's looking at larger nets now as well. That's something. So what we want here is we want it to look for... It's probably going to look at like smallish networks, very high throughput, and then it's going to look at larger networks with lower throughput is the goal. Weird that it's not finding anything. And this is more balanced, though, at the very least. Length of experiments is only, it's one axis, right? So length of experiment, that's one cost. The other cost is the amount of data. The reason I'm using Pong is because you can solve Pong in 3 seconds, and you can solve it with less data in like 20 seconds. So it's got a very short timeout here. And that should be enough to get me a lot of experiments very quickly. Well, we'll see what this does. This has a hope, I'd say. I don't think what else we can do though, because I don't like falling into this trap of like basically just sitting here for 5 hours watching experiments and not building stuff. I also don't like sitting here falling into the trap of hand tuning hyperparameters though. That's super obnoxious. Like super, super obnoxious, right? Like, there's gotta be something to do other than just, like, wait for these stupid experiments to finish repeatedly, right? I wonder to what extent... I can push it. Depends on what, like, what are you interested in looking at, right? Because I can push stuff. Than this thing, but I had to do. My FBR. Work on an environment. You know, you're probably right that I should just, like, do something like that, because it'll be fun. It'll, like, that would be a fun thing to do. It's so difficult that I, like, can't force my mind to do stuff. I'm just like, ugh, I don't know. But the thing is, I don't think that this problem is going to get solved by just waiting around either. Everything. Okay, let me at least clean some stuff up on this. More I want to make. I probably should do some stuff like that. I mean, realistically, there's a ton of stuff. There's stuff I could be doing. I'll go look at some old experiments. The thing is, that's too heavy. Just like I don't have the energy for like these few days here to be doing that. That's too much. Oh, this is horribly slow, right? Suppose I can use it. Dude, this... I gotta get a better logging tool. Neptune has just gone to shit. Okay, better. Learning rate, gamma, lambda. See you, Owen. Missed a message, Jess, I think. Wait. M seems best way. Do some code. Well, but the thing is, Jess, like, I can't just procrastinate on this thing either. Like, this is the most important thing to be working on right now. It's just a matter of getting myself to actually, like, focus on shit. Hey, Weston, welcome. Let's see if I can fit. I'm just gonna see if I can fit something that's, like, cleaner here. Let's see if this makes a difference already. Actually, this one I don't know, to be fair. Leave it for now. Okay, so the hope here is that we've restricted the search space a whole bunch. We just need to be really disciplined, I think, about. You just need to be really disciplined about running these experiments. Okay, see, we're already getting somewhere. Now, hopefully this just cranks a bunch of experiments quickly. And with having, like, sane defaults for stuff, we can figure out some sort of fit laws. Then, of course, we'll have to see, like... I guess what we'll try to do is we'll try to get, like, a restricted hyperparam sweep going. We'll, like, reduce this to as few axes of variation as is reasonable. We'll sweep those so we don't have, like, hard-coded Pong-specific defaults for anything. Heck, I was fitting the defaults off of a different env even. We'll see how good we can get out of this compared to doing the full sweep. Basically, be able to figure out, like, number of degrees of freedom we actually need to have in this thing. RAM speed bottlenecks. I have not measured, frankly. I don't think so, but I have not measured. I mean, realistically, you would expect that the answer is yes, though, right? Because, like... more of a software issue than a hardware issue. It's just not doing proper caching optimization. Alright, well, I mean, at least we're getting a range of different experiments now. I'll be interested to see if this quickly gives us, like, a set of usably good experiments, right? That's the key. Is if I can just, within a couple of minutes, or a few minutes even, just get a usably good set of experiments, start sort of tracking how our hyperparam sweeps are going, probably way better. Yeah, so like here, for instance, right, we have a solve at 8 million steps. Nice. Go check some things on this. Use a restroom real quick. And you'd build tiers of environment models. What? Oh, I missed. Have I been looking at ways to optimize the physics? No, I have not looked at that. So the thing I'm always skeptical on like learned physics models is if you're doing RL against the models, you're gonna poke holes in it, right? The reason I think the reason that world model stuff at least is supposed to work on paper at the least, is that you're getting fresh data to patch the holes as you find them. I don't know if this stuff makes sense without that. And heck, for my work on world models, stuff just doesn't work very well in general without a ton of compute. Alright, I'll be right back. Give me a minute, folks. Okay. Running bigger models. Interesting. Okay. It's actually finding it's actually found itself some good experiments already. This is nice. Yeah, look at that. It's actually starting to find good experiments and not that many trials. That's a stark difference, right? That's a very nice difference. Now, they are all up against the max time, but that's fine. Huh. Well, I mean, this is interesting, right? Look at this. So we now have... Wait, is that 400K? Am I reading that right? It is. Wait, that is. Ooh. Oh, but wait, no, this is not. Hang on, I'm dumb. Yeah. Okay, we're a little dumb here. Alright, that's more reasonable. Is normalizing inputs always a good idea for PPO? No, it's just a rough guideline. Where on the chart is the model? These are all different models, right? That's the idea. I mean, so this one here, this is a, like, 3 million step solve in 30 seconds. Should I bother normalizing? You may as well just divide by... I mean, if you literally just divide by 4, Weston, that's good enough. Though if your inputs are 1, 2, 3, and 4, that's a different story. Now you have categorical data. Right? Puts one over here. Interesting. Now, probably there's some reason that this is at max cost. Ah, you know what? It's being clever. It's actually using this to get around my... It's using the time cutoff to get around my constraints. Because, like, all it has to do is make the run slower and slower, and it's technically a Pareto point, right? Yeah, so it's literally just optimizing. It's trying to find the slowest run possible. It depends, Weston. Like, if you only have like 0 and 1, it's kind of fine. It really depends on the data. Usually, yes. But it depends. That's an interesting one, right? 4 mil, 2.8. Yeah, that's good. Like, gets added here. Let's see. I'm trying to think if I need to massively rethink. Maybe I need to rethink the way the algorithm is going, because the problem is we want to cap the total time spent. But then if I say, like, hey, fewer steps is better, that's actually, now we have the exact same problem from before, right? Where it's like minimum time or minimum steps becomes attractive, right? Because if you can just find the fastest possible run, that's technically a Pareto point, even though that doesn't freaking help us at all. I thought I was supposed to not have that issue. I mean, I clearly do see it, though, so if I see it, then believing it. It's an exploit FBR. It's not. It's an edge case exploit that I'm dealing with. It's not like a core thing. What's the y-axis? So they're two different charts. The main thing we're trying to figure out is we're trying to figure out like data efficient runs and compute efficient runs. This actually, would this not be good? Wait, this shouldn't have the same degeneracy, right? Yeah, I explicitly designed it. Like, I was smarter than that, right? I, like, explicitly designed it to handle this. See. Okay, so you get search centers. Predict scores and costs. And target is... Yeah. And maybe it isn't being weird. Hang on. It was only being weird before. I don't like that all of the experiments here are above 30 seconds. I suppose we are competing. The two different costs are competing, right? Instead of doing a minute, it would be easier to just do half of one and half of the other, no? I think that would be better. That way I don't have to deal with, like, relative normalization horseshit. Yeah. Uh, that just actually did, that just did something, didn't it? Yeah, look at that. Out here, we got this point. This also doesn't give us our nice Pareto front now, does it? Yeah, these tools, like, actually, these tools here are not designed for this at all. Kind of tempted to do my own custom log thing. This would give us a nicer Pareto frontier as well. Hmm. This is cool. I do wish I had my local machine for this, because otherwise it's actually kind of obnoxious to try to like host a thing. I wonder if there's a way I can do it. It'd be kind of funny if I just did it in PufferLib, wouldn't it? In my own damn plots. I could do it really easily, actually. Be funny. Still doesn't solve the hosting thing. Well, get log transformed, right? I suppose this can bias you one way or the other, right? Can bias you one way or the other. Okay, but at least we have something more respectable now, right? Like a good baseline? Okay. And do the same thing now here. All right, so we're going to spend half of the time looking for sample efficient runs and half the time looking for data efficient runs. Yeah, we got 50-ish runs here, right? Let's look at our samples. So we have all these samples up here. Over time, they do get more accurate on doing well, but they also all clumped up in the high time zone, right? So it kind of only filled out. Look at this front. Okay, so like this one here, it really didn't fill out much of a front, right? it kind of just did a bunch of long runs. It looks like it was just trying to win on samples mostly, right? A couple exceptions. Yeah, look, you can see it's pushing down over time. It was just trying to win on samples. Not what we want. We want explicitly this thing to cover both cases, right? Okay, so now we should be able to do that. We should be able to do that much more explicitly. Now we don't have the normalization thing going on. A few decent runs already. See how this goes. I'm trying to think what the smartest thing to do is when I don't want to be building my own stupid dashboard application, but like did that during my PhD actually. There's some super old screenshots you can probably still find from my PhD where I had like my own custom dashboard for neural MMO. It could just have it save like a nice plot image, I suppose. It's difficult when I can't even say exactly the format of the thing, like the thing that you need to be monitoring. I think I can probably get something to work though before I fully know that. I mean, this is getting better. Steps goes up. Thing. I was trying to solve. Get some quick runs, yeah. I mean, they're kind of two separate issues. I suppose I could do like pure sample F, right? Could just do that. If we were to give this thing a 1-minute timeout, just go purely on sample efficiency, what does it do? It's doing good stuff at the moment, to be fair. Maybe we can just do it this way. Not this one. Because, like... But is this going to get both sides? And so far... And we've got these two. This is reasonable. To be able to be pushed down. I mean, we know how this should technically work, right? Whether puffers in the spaceport to work is another story. Like technically it should be stuff like fewer environments, more updates. That sort of thing should improve sample F. This is doing stuff now, at least. And this is a ton. This is going to be a high samples, super fast one. But like, oh no, this is good, right? Like, it's going down this way on both sides. Maybe this is it. Maybe we actually have gotten it. It'll have to be a question of how much better. It always runs for way too long is the other thing. Just stop. Both steps and samples. I actually wonder if the downsampling is messing. It could be, right? Hmm. Here's a nice one. So what did we find here? It's 4 million, 10 seconds. Oh, yeah, so we already found something better with this than with the old method, so that's good. Yeah, this is an improvement. Next question. Downsampling's messing it up, I suppose. We can measure that one pretty easily. I expect it to. Be a little bit. That's a really good result. Wait, what? Isn't it? Okay. Well, I think we've gotten it, guys. So 8 seconds, 3.7 million steps. And we've only done like 40 runs. That's good. That's very good. And then it knows, right, like that technically, I believe this point's also pareto. This is sub 3 million. Oh, and this uptime thing is not even the... It's actually a little faster than this as well. Hey, FBR. So if you think of this, right, like, the original PufferLib baseline is 3 seconds for 12 million steps. So what this says is that we can, instead of spending 3 seconds, we can spend 8 seconds, and we can cut the amount of data that we need in 3. Potentially very good. Yeah, and look at that. It's actually filling in nicely now, you see? It's like looking for runs. I do actually wonder, though, with this cost thing. I have another thing to try after this. We're giving these like 50 runs a piece, I think. I have another thing to do. Straight up steal your idea and beat you to it for paper submission. I mean, you can do and it'll be published, but if you don't give attribution, it's going to end up in not looking too good. I don't particularly care if people want to formalize and publish my stuff as long as it's attributed. Because I'm sure as hell not doing it. I'm doing blog posts now. Oh, my. Yeah, so I definitely think then that do we do I mean, it's just dumb, honestly. Academic, like, drama is just so stupid. Just, like, shut up and actually improve science. Get out. What we change here. If this makes any sense, actually. Plug this in. So, let me think. Log costs. The crazy thing to me is if you like actually read academic papers, like as a whole in this field, like a used car salesman is going to be more honest than your typical paper with the way that the results are presented. I'm just trying to think here. I actually don't know if this needs to go negative or not. Maybe this is just fine. I think it can go. We'll try this next. But this is like a pretty solid... Oops. On. Okay, I mean, this is pretty solid for our set of 50 runs here, right? You literally don't even have to do that. We are. This will attempt to do cheaper and more expensive runs. Yeah, we will see how this goes. If you have appropriate credentials, then pretty much, yeah. And dude, Silicon Valley founded fucking Theranos. Like, come on. Okay. I mean, this is a result. Like a decent start. We can just leave this. Well, we're gonna see if this beats it. And then after that, I think we're gonna just leave this to run longer. And we'll see what this does. It's funny that we don't have points down here, right? But presumably those will get explored eventually. There's only 50 runs. The coal graph. Let me think of something else. Let's try to see if I can think of something else I can do or some other way I can start making progress here, because I really don't want to spend all week just like staring at little fiddly experiments. I guess we can do... We make multi-GPU sweeps just work. Be really nice, wouldn't it? Is there an easy way to do it? Be really nice. That would actually be the best thing, is if we could just get multi-GPU sweeps. Compile working? I think it should be, but I haven't used it in a while. Now, but we don't do compile during sweeps because it literally takes longer. It takes longer to run the compile on short experiments than the time you would save from it. I think, what's the simplest way that we could get multi-GPU sweeps? I guess sub-processing it. And get something like that to work. Something crashes, you're not going to get the freaking error, but... there's standard for action masks. Well, there's not a standard in Puffer because we don't do it normally. We don't have action masks in Puffer by default, Weston. You would add it by some way, and you would add it by masking out illegal actions. And the way that you mask out illegal actions is typically, unless you're going to change the sampling, you'd have to set logits like negative infinity or something, right? No for inputs. I mean, no for inputs. Wait, what? No for inputs. I don't know. Parallels. What? Output props. Yeah, so like if you look at the sampling logic, right? When we call sample logits, I think you'd have to set the inputs of invalid actions to negative infinity or whatever. Or add it as a feature to do the same thing. What we can do about this. I don't like the idea of having to subprocess the frickin' thing. I mean, nuts. Can't thread it though, because Python doesn't have. I could subprocess for now, and like we'll eventually replace with the reds. And triple triad doesn't have action masking. Oh, also that's like one of the envs that has really bad code, by the way. That's like Spencer's literal first env that he made. Like crazy nested pointer shenanigans. Ah. Eh. Uses action mask. Dispatcher loop cycles through. It's you can't just do that. I'm at the very least gonna have to throw the whole train thing into a sub process, which I hate. I can look how I've done this on. Well, because you need the CPU. It's a CPU intensive thing as well. This is kind of okay though, right? I should merge. Let me finish this. We'll merge this, and then we'll try to do this on another, like on the multi-GPU box. The play. If I can get this to work, it would actually make a big difference, to be fair. Yeah, this has not produced a single thing of worth, so we're going to kill this. This. All right, cool. So this, number 1, 2. All right, let's go to buffer. Okay. Train and name args. Okay. I think we can do this, right? Do I not have my Super Maven on this? Oh, I don't. God damn it. So obnoxious. Whatever. Colon hierarchical. Yeah, I don't know. I don't know what's going on with that. Yeah, there's something to world models, but I mean, it's like the same old, where the quality of the lit just sucks. So like, I'm not spending my time cleaning up everybody else's messes when I have other things I can do to improve such, right? Okay, they're the workers. Just do like this. Be easier. Can I just like want to do this on the box that actually has a frickin'... Oh, that's okay. Going on this. All right, so something like this, yeah. I think something like this. Ever done anything with robotics? I mean, we have the drone M's. We haven't done. We've also done stuff in animation with, like Isaac Gem, old Isaac Gem. But we haven't gone super heavy into robotics. I honestly don't think it's going to be the biggest area for RL at all. Now, I honestly do want to spend more time on material science. There's just some jank stuff with there's like some jank fundamentals to be addressed. Like it feels wrong for me to step like very deeply into a specific application area um with the state of the field still being what it is, right? Like it really just needs to be a bit better. Like we can totally get stuff to work and we do for clients, right? But like it can just be way better. And I can definitely do that for sure. Mm, maybe. All right. Fuck is wrong with this? Oh, you dummy. There. Time is it? 30. Now I am actually starting to get hungry. That's star restrict. Like keyword arg only restrict. Yeah, because it's stupid and Python's a stupid language with too many stupid features. Honestly, we use too many of the stupid features as is. You mean like star in a list so that you like mandatory keyword args? You mean like the mandatory keyword args? Strict end. Wait, what? Destruct star. Yeah, because I don't know what the hell that is. What does that even do? I thought you were talking about something completely different. The pointers. What? I didn't know about that keyword. That's weird. A lot of lower level optimizations, you actually need to either know quite a bit about how the compiler works or you need to time aggressively to see if it does anything. We don't do a lot of sub pointers though. What? Right, so it wants this bullshit. This here. What? I have no idea the distinction you just made. We wouldn't have this issue if it was written in Haskell? Yeah, because we would have all... shit, you're not allowed to even say that on the fucking YouTube. Whatever. I would not be in this line of work if I had to write everything in Haskell, let's say. Yeah, exactly. Oh. So annoying. You're gonna have to send me a proper example somewhere, Weston. Like you have to be a little bit careful because if you're not timing shit, like you can come up with all sorts of things to help the compiler and you just make a mess of your code with like a bunch of extra keywords and shit, and then it's the exact same or worse. All right, well look. Did you actually time it? 13%. I'll just see the code differences and such. Oh. Kind of ask that there's just like more keyword. How does this let you simplify shit? Like, what could you have not written without this keyword here? What the heck? Why are you doing OMP shit? What? Yeah, why are you doing OMP shit? Hey, Smog, welcome. Oh, hey, Aziz. Okay, well, Grok is fucking with you, so you don't need to do... You don't... You shouldn't need to be doing that on your own, because the thing is, Puffer's bindings is just taking care of that for you. And if I were going to do this... If I were going to do this in C, like, each block of M's would just get its own thread. I sure as hell wouldn't be trying to do multi-core anything with a bunch of macros. I penned. Yeah, well, it's a sim, right? Interesting. I'm not saying it doesn't work. I'm just saying you're making stuff complicated on yourself. You need to write C code to create a custom M. You can write Python for custom M's, though we highly recommend that you try the C. It's going to be very, very fast, and it's going to be a lot easier than you expect if you look at some of our examples. That is the recommended, though, for custom M's is, yeah, that you use our native API. You can also bind existing, like, Gymnasium and Petting Zoo M's in about one line very quickly. But, I mean, for the most part, you're never going to get close to the speed that you can get with our native envs. Template. I don't necessarily think that helps, honestly, because if you're thinking in Python, you're going to do it wrong. I would check, like, we have a template env in C. I would suggest just copying that and using it as a starting point. Here's your restroom. I'll be right back. This is why I didn't want to do frickin' sub-process bullshit. He's messing with you a little bit. Well, we have guides on X. If you click my articles tab, there's a comprehensive guide that will get you started with Puffer. And so this loop actually does run. Enough. There we go. It's just Python being shit. Like, this would be way easier if, the thing I'm doing is not, like, normal with Puffer, and it's only, like, this is literally just Python being a terrible language. Honestly, this should be fixed in Python 3.14, though, and then, we'll actually be able to thread instead of having to do this horrible mess. Oh, that's terrible. Huh. You're gonna break everything, I'm sure. Yes, it works. Oh yeah, this is, I don't have my normal editor on this box. This is just like default vanilla Vim. I don't even have my Code Complete plugin on this. I kind of just been writing stuff. It really goes to show you, though, the fact that I can do this and it's, like, not that much worse. The AI's, like, the plugins really don't do that much. Mostly just on you. Really? Good blogs. The thing is, I did write so it's on the website as well, but there is a comprehensive guide, Smog. Like most of this stuff is just in articles. Like if you read this, this is a detailed guide. This has links to everything else. This is all you need right here. This is a complete reference with everything that's linked. It's a lot of material to work through. Isn't it CUDA colon? Is that, do I have it wrong? That document is though, like, that's not dated. Code examples. That has code examples though, is the thing. That has like extensive code examples. It's just that they're linked to from there instead of being inlined. Because if I inline them, then I have to keep them updated all the time, right? Whereas if I have them linked, then they're automatically kept updated. Here. If you actually look through this thing, right? It says, okay, do this on the squared environment. Cool. This is in PufferLib, right? Then there's, where's the other one? Oh, yeah, here. It says, read the docs. Okay. Docs. We start here. Here's this thing. Okay, we go here. Here's code, right? And then we go back here. Okay, here's code. Here's code, right? It's like it's all linked. There's not a ton of stuff inlined because it gets outdated. But, like, there is a bunch of code it's linked. There are, like, you know, many hundred lines, probably many thousand lines worth of examples in here. Hmm. Working environment. There is working in, well, it's not like it's integrated on the site where it's like you have the code on one side and the end. Like, yeah, there's not UX done on that type of stuff or whatever, but the stuff is there. I honestly hate stuff like Obsidian. I really don't like any of these like fancy organizational apps for thoughts and knowledge and such. Heck is this? I don't know. Whenever I was made to take notes in like school and like college, right? I literally would never once read them. And I was like, okay, what the fuck is the point of this? Okay, that's weird. Weird. Yeah, but that type, like, I don't know. I used to think like, oh, I should be more organized. I should do this. I should do that. And then it's like, I tried various things, and there's really just no substitute for the very simple approach I've taken. It helps some people. It doesn't help me for like at all. Like I want less structure, if anything. I'll know I've made it when I have no public email, no calendar, no other sorts of things of the type at all. I I work on like I hone in on a problem. I work on it very hard for a few weeks at a time. I look at it in ways that it hasn't been looked at before. I solve the thing. I either write up or put out, a piece of work on that thing that I've done, and then I take some time to think and regroup, and I go to the next one. What time is it here? My watch should be charged, right? 5:30, 5:20 something. I usually go to dinner at 6 and I am starving. We're going to see how much longer I'm doing this cut for. I said that I was going to keep this up though until either I'm done with California or until I start losing strength. This is week 5. I am hungry. 2 a.m. The results have been very good so far, though. Brought you to California. Palo Alto is nice in the summer, and there's business around. Your chat mainly Europeans? It depends what time I'm streaming, right? Understand what you're seeing? If you stick around, you will see, like, it's actually a lot easier to get into a lot of this stuff than you'd expect. We have brand new programmers who have gotten RL working on new M's that they have written that are fast in C. So, I mean, RL is like 1,000 times easier to get into than it was a year and a half ago before Puffer. Knows how to party. I used to know how to party. And I did too much of it and got sick of it. So weird. Right? Thank you, Weston. Some of us have M's running at 10K. That's on you. Oh, that's weird, isn't it? Yeah. New graphics. Should I write in C? Yes, you should write in C. We use Raylib for graphics. Raylib is really, really nice and easy to use. Like, so graphics is basically taken care of for you because it's just the best library ever to use. And the env logic, the way that that is hooked into Puffer, is made very easy for you. You pretty much just get to do low-level game dev, or low-level whatever your application is dev. Get rid of this thing. That's cool. That's doing stuff, right? Yeah, Raylib is great. Like, Raylib is truly... I gotta say, Raylib's the best library I've ever used. Yeah, I've gotta give it to the library that's pure C, right? Because, like, if we're looking at Python stuff, like, yeah, there's NumPy. NumPy is revolutionary for that. But, like, Raylib is just so nice. Mini GPUs? Oh, yeah. So, The other cool thing about Puffer is we have hardware, and we do give repeat contributors access. Where is it? I will show you the Puffer training facility. So I missed this place. I will be back there after I'm done in California. We have all the hardware in the background for training agents, and then we have all the equipment for training me. That was fun. The two tiny boxes there are 6 GPUs apiece. I think I should still be able to be lifting this no problem, and I'll probably be like 15 pounds lighter than when I left. We'll see on everything else. KCD. Oh yeah, this. Yeah. You have to be really stubborn, is the thing. Okay, wait. 1, 2, 3, 4. Is this running, like, efficiently? Oh, yeah. Interesting, right? But it doesn't seem like it's way faster, right? 2, 3, 4, 5. X article on my gym stuff. I do post the occasional fitness article. There will be one on the training block that I've been running for the last month. Soon. When I finish it. I'm still not sure whether I want to post physique pictures, because I don't usually do that, but the results of this one have been very good. And unlike normally I'm posting stuff that's like, a strength goal or like a running goal or something. But the main thing with a cut, right, is the physique difference. No, it's Unsloth is LLMs, man. Like, the stuff that we do has to be 1,000 times better optimized than any of the LLM stuff that's out there. It's a totally different data regime. Like, basically anything that's been designed for LLMs will just fail hilariously. What the heck is wrong with this? This is not doing this. are we only getting one? Yes, Jess, it's one of the things I get the most number of people emailing me about. Speaking of which, I was supposed to talk to a guy today, but I forgot. No biggie. Tired. I'm really just exhausted this week. I don't know. It's probably the cut. Probably with less food, I should be like, go get myself a vitamin supplement or something, see if that helps. But I think it's most likely just the damn cut. Thanks, Mog. There is a Discord, discord.gg/puffer. If you're interested in that. Lots of helpful people on there. Pretty much everyone on the stream's on there as well. Yeah. Yeah, you're just kind of in a tough spot, man. It gets better. The heck is this thing doing? Stupid thing. Is it not? Hang on. Predicted. This is on suggest, right? Yeah, it's on friggin' suggest. Why did I try to write a printf in Python? Can somebody tell me that? Ah, it's trying to suggest a billion things. Go away, Jess. Go build chess env. They're trolling me. Let's see if this does it. Okay, this is actually now faster, right? There's some overhead, but it's faster. Yeah, that's actually substantially faster. Perfect. These prints. Oh, that's nice. 7.6 seconds under 3 mil. Solid. Ah, and this is actually running. Very nice. Lovely. And we will do there. We'll see how this goes. Big sweep. Multi-GPU. Initial test. The first multi-GPU sweep I've had going. At least with this algorithm nicely. We got a chunk of multiprocessing work done today. We got some nice new baselines running. This thing's still going as well. Check this out, right? We have this nice thing here. This graph. We can just go. We want all of the solves. Takes 70 different runs. And then our best here, we have our front. A couple over here. So on and so forth. Very nice. That's a decent chunk of work done for now. I'm going to go get dinner before I starve to death. A couple people that are still here watching, thanks for tuning in. It's going to be a little bit more slow work for a bit until we get into a bigger new project. But this type of stuff's important. Like, if we get this to work, this will just be so much more polish on Puffer. And this will let us, this will basically let us throw Puffer on a lot of new types of problems very effortlessly. Alright, cool. Well, my stuff is at puffer.ai. This live stream is supposed to be... Okay, that's messed up. But anyways, start of the repo helps me a lot. Join Discord. Want to get involved? And follow me on X for more content. Other than that,